So we have seen what is the concave and convex mirrors. Now we have to see the position of the images, the figures we have to see. Mind well, on this chapter you will 100% will get at least one figure of images. Okay, suppose the image is at some point, where will be the reflection, and so on, and one example. These two things are must in your paper. Okay, this chapter page wise, convex, concave mirror and lenses is of 11 to 12 pages. Two or three big tables are given, okay, here to by heart. But according to me, the figures are extremely simple if you know how to draw the figure. Incident rays, parallel reflecting rays pass through the point of focus. Okay, if you remember this, you will perfectly get the figures. You don't have to remember any table. So in case of concave mirror figures, let us learn how to draw this figure first. First of all, draw a straight line. Okay, then use your protractor and draw concave mirror. Okay, protractor, you have to take 2 points. One point is a 0, another is a 90, and draw concave mirror. Okay, now this is very important. You have to draw 2 points. One is your point of focus and second is your curvature. Okay, center of curvature. You should take exactly same distance from here. Suppose point of focus is at 6 from here. Suppose I am taking, this is F, then same distance you take from F, C. Okay, this is your pole. Okay, now you have got 2 points. One is your F and one is your C, center of curvature, and F. Now we are going to learn 6 figures. That means the object is placed at a particular distance. Now where the object is placed, suppose object, the first is infinity. I am just writing I for infinity. The second figure, object is placed between infinity and C. In third, object is placed on C. Fourth, object is placed between C and F. And the fifth, on the F, and sixth, on the F and pole. This is your pole. Okay, very simple. Now I want you to draw object on the upper side of your principal axis. Okay, except in case of infinity. In case of infinity, there will be no object visible. The rays are coming from the infinity. Okay, now you have to take 2 rays from, I am drawing a rough figure. Suppose this is your object. Now this is generally shown, arrow is shown in your figure, but whenever you are drawing in exam, don't show the arrow in the beginning, because we want perfect points. If you miss this, because arrow will destruct your point. If you miss the perfect point, your image will not be there on the right place. Okay, so don't draw the arrow first, only draw a straight line. We want 2 points. Okay, now from this object you are going to incident only 2 rays. Okay, suppose this is my C and this is my F. Wherever the object is, one ray will be parallel to principal axis, and second ray, keep in mind, second ray will pass through the nearest point. For example, from here the nearest point is C. We have only 2 points, C and F. So nearest point is C. So the second ray will pass through C. Now, whatever is going parallel, then it will reflected will be passed through some point. Whatever is going through some point will go parallel. So the reflecting ray of the line which is initially passing through some point will now be parallel to the axis. Okay, and suppose this, and since this incident ray is parallel to axis, this will pass through F only, this only. We'll draw it properly, I'm just showing you this. Okay, I am telling you again. From the object, always draw only two rays. One will be parallel to principal axis, the second will pass through the nearest point and incident on the concave mirror. As a reflection, the ray which is passing through some point will go parallel now as a reflection, and the ray which is the reflection of the parallel ray will now pass through F. Okay, if you remember this and if you carefully draw the figure, your image will be exactly where it should be. Okay, remember again, draw principal axis first, then with the help of protractor draw concave mirror. Okay, now we have to see these points. We will draw incident ray by red pen and reflecting ray by green plane. Okay, now as the rays are coming from infinity, that is, suppose the rays are coming from some star which is the light years away from us, what will happen? All the rays will come parallel because they are coming from a very, very long distance. In this case, we have to show only two rays. Okay, so I am taking this image or object on infinity somewhere here. I am taking this, only in this case the object will be like this on the both sides of the axis. Okay, from infinity the incident ray, so from infinity two rays are coming parallel to principal axis. These are the incident rays, and the reflecting rays, since I told you whenever the parallel rays are reflecting, they will pass through F. So both the rays will here pass through F. Okay, the reflecting ray will pass through F. After completing the figure, draw arrow. Don't draw arrow initially. Okay, so what we generally see when a long distance object is there, we just feel it's a point image. Okay, so whenever the rays are coming from the long distance, what happens? We get both the rays concentrated at F and we get the point image. You know, most of the stars are bigger than our sun or moon, whatever it is, even earth, sun, moon. But what you see in the sky, we see only points because they are coming from the infinity. And in our eye also lenses are there. Okay, so we just see the points here. Now we have seen when the object is at infinity, there we took only parallel rays. Now let us see all these 5 figures. Let us draw concave mirror first. I am taking equal distances F and C. So I marked here C and F here. Now we are going to see the second case where the object is between infinity and C. Let us take this object somewhere here. As I told you, do not draw arrows first. Now we have to draw two rays. One ray will always be parallel to principal axis. Okay, So one ray I am drawing parallel. One ray I am drawing parallel to principal axis. And another ray will pass through C. When it is passing through C, it will just rebound. It will just reflect. Okay? This ray is passing through C. Now, after incident, what will happen? This ray will reflect back in the same direction, but the parallel ray will pass through F. So, this parallel ray now will be passed through F. The ray parallel reflection is through F. The ray passing through C, it will bounce back. And a point of intersection, that means when it is bouncing back and your point of intersection is this. At the point of intersection, you will get an image. So, you will get image at this point. Okay? So, you are getting image on the downside, opposite side of the object. Now you can draw arrows. So whenever the object is an infinity between infinity and C, how the image is there? This image is real and inverted. It is inverted and real and diminished. That means it is a smaller than the object. Okay? In this case, you have to draw all the figures. Now let us draw, or let us take the object on the C. I am drawing on the same so that we will understand this. My object now is on the C. My object now is on the C. Now one line is parallel, it is going same way. The ray will be the reflection. This ray will not change. This reflected ray will not change. Now, from where the second ray will pass? Now, it is generally it should pass through C, but here the object is already on the C. Then what to do? Simple. Then we have to pass through F. We have to pass this incident ray through F. Mind well, whenever the parallel line is there, the reflection is passing through F. Now since this is passing through F, the reflection will be parallel, just opposite. This will go now parallel. And you will get image exactly on the C itself, here. The point of intersection is here. Since I am drawing on the board and this point of marker is blunt, it is not coming at exact point, but when you are drawing with the pencil and taking the exact points, your images will be more accurate than that of mine. Okay? So whenever my object is on C, what is happening? One ray is going parallel, incident will be passing through F, always. Now here there is object itself is on C, so it will pass, one ray will pass through F. Since it is passing through F, the reflection will be parallel, and where these two rays meets, we have an image. Now this image is also inverted, real, but of exactly same size. The image we will get is inverted, is real, and exactly same size of the object. Now, what is the next point is? Next point is between C and F. Let us consider the images between C and F. Since this is complicated, we will rub this and draw another figure. You can draw these figures very fast if you use the protractor and scale. Otherwise, if you try to use compass, the figures, it will take much more time than this, okay? Because you have to draw figures very fast. So I marked F here and C here. Now the next case is between C and F. I'll take it somewhere here. So now my one ray will be parallel and another ray will pass through C. Now since it is passing through C, it is something like this. The ray which is passing through C will definitely rebound, okay, and the ray which will be parallel to principal axis will pass through F. Now can you see where I'll get, mind well, you have to mark these arrows. The arrows are important. Then in the figure you have to draw the reflecting surface, so non-reflective surface also you have to show, okay, you have to show the figures perfectly, okay. So now where I am getting my point of contact, it is here. So let us draw image. Let me extend this, and now I am drawing the object. So this is my image. How is the image? Now I can draw arrow after completing the figure. Again I am telling you, while after finishing your figure completely, initially don't draw any arrows. After finishing, show this non-reflective surface, show the incident ray, show the reflection, all the arrows you have to show, okay, that is must. So now where the figure is inverted. It is real and it is big. So whenever the object is placed between C and F, how will be the image? Image will be magnified, that is bigger one, magnified image, inverted and real. Very simple. I have not taken any measurements, I have not tried to by heart the table. Whatever they are given, I just went on drawing the figure and I got the image exactly on the same place as your chart shows. So you need not by heart the chart. Whenever you are asked, then just draw the figure and find it out, because one of the figure will sure going to come in your exam. Now I have taken between C and F. Now next is exactly on F. Now my object is here on F. What will happen? One ray will go here and incident ray will be same, and one will pass through C. Now can you see that one ray is going parallel and then passing through F again, and one ray is passing through C, and which is bouncing back, okay. Can you see both the lines, both the rays are parallel. That means we are not going to get image anywhere, or we can say that we will get the image at infinity on the downside. That means inverted. If it is inverted, it must be real, and it is highly magnified. Highly magnified image. You will get the image somewhere at the infinity, very big image, okay. So we have seen fifth type also. Now the last is remaining, that is if we put between P and F, that is pole of the mirror and focal point, what will get? We will draw the figure again. F is here, C is here. Now my object is somewhere here. As usual, one ray will be parallel to principal axis and one ray will pass through C. This ray is going here. Now let us draw the ray this ray will pass through F. See this distance and see this distance. What you can say? These rays, these reflecting rays are not going to meet because they are going apart, they are diverging. Okay? So on the same side here you will never get image. So where will the image will form? Now let us have the virtual image. I will extend this. I am extended this ray here and I got the point of contact on this side. I am increasing the principal axis virtually. Okay, and so I got the figure, or I got the image here. So I will say that this image is virtual, erect, magnified and beyond. Okay, you will get this table in your book, don't worry about it. Okay, so when these rays are not meeting on the same side of the mirror, what will happen? You will get a virtual image. The virtual image will be magnified image on the opposite side of the mirror, which is erect, then magnified, and it is called as virtual image. So we have seen all these 6 figures. One thing I must tell you that you need not by heart the table. Okay, even if you draw on the back of the paper a rough image, you will immediately come to know where the image will be according to object. So mind well in this figure. First draw principal axis, then with the use of protractor draw concave or convex mirror, whatever it is. Then take a same distance from P to F and F to C. Sometimes one more thing I want to tell you is your foolscap paper, that is your answer sheet, is like this, and many times or most of the time it will not possible to draw these figures on this sheet. Your answer sheet is like this, vertical, so you have to draw figure horizontal. Okay, you have to draw figure horizontal, otherwise it will not fit on this width. Surely it will not fit. So you have to draw the figure horizontal. Mind well that points must be perfect, only then you will get the perfect image. If you use the blunt pencil, you will not get perfect image. At the end you have to mark all the arrows. Okay, you have to write the conclusion. You have to write that object is placed between C and F, like this. Object is, your answer should be something like this. Object between, now I am writing in short form, but you have to write in full, between C and F. Image is inverted, real and magnified. Okay, your answer should be very, very clear. Okay, don't write in short forms like this. This is just for you to remember the figures. Where the object was placed at infinity, between infinity and C, on the C, between C and F, on the F, and between F and P.